Hi, everyone. Thanks so much for joining us today. I'm Chloe, and I'm with the Tri-County Regional Energy Network. And today we have a very special 3C Run training. Judy Rachel is here with us to answer all of your questions on high performance enclosures. And before I pass things off to her, I do have a few opening slides to go through. We are recording today's training. You're going to be receiving a copy of the recording as well as any slides that we go through today in an email in the next couple of days, so keep an eye out for that. Today's training is also meant to be very interactive. We want this to be a conversation as much as possible. So if you're comfortable, we're going to invite you to turn your cameras on, unmute yourself, and please ask questions whenever they come up. You can raise your hand and ask them over video, or you can also add them to the chat, whatever you're comfortable with. But whatever questions you have for Judy, she is here to answer today. We'll have some materials prepared to kind of get us started, but this is really meant to be driven by you guys and your questions for her, so don't be shy. I also wanted to mention that at the end of the hour, I'll be launching a Zoom poll. If you can take this, it really does help us out. All of the feedback we get from our trainings, we use to influence our future offerings. So if you liked this training and want to see more of it, definitely let us know in that survey. If there's anything else you'd like to see from us, let us know. We're always looking for new ideas that are generated by our audiences. All right, I can go to the next slide. Thank you. I did my slides as well. Okay, we are the Tri-County Regional Energy Network, aka 3C Ren. 3C Ren is funded by ratepayer dollars that we all pay into in our utility bills through the public goods charge. The benefit of being ratepayer funded is that there is no cost to those we serve. And as a regional energy network, we are able to return these dollars back to our local economy, which has historically missed out on a lot of this funding. And then before I pass things off to Judy, I just want to tell you all about our programs we offer through 3C Ren. We have 3 service areas: incentives, training, and technical assistance. Today's event falls under our training category through Building Performance Training Program. To see more events that we're hosting and learn more about our other programs, you can visit our website, 3c-ren.org. And with that, I will pass things over to Judy and all of you.
All right, so this is just a quick slide, about me and the various things I do in the high performance, home performance, building science niche of construction. And so what we want today to be, and so thank you, Chloe, so much, and 3C Ren for giving us this opportunity to have this office hour. So this is, me in my home office, my high-tech home office. How I see this and 3C Ren sees this is that, you're coming in to visit me for us to have some conversations about enclosures in particular, to anything that you've seen in an enclosure that you've been wondering about, or is just something that you've heard about that you're curious about, or maybe you're experiencing something in a home or in a building that you did an inspection of or something like that. So we want to just have as if you're coming to my office over this Zoom, and us having some conversations and knocking ideas around back and forth about what's going on with this issue and how might we figure out how to solve this issue. So as part of all of that, as it wanting it to be a conversation, I offer that you respectfully unmic yourselves. So if we all take a look and see where the heck our mute and unmute audio button is, so that we're familiar and know where that is. And for anybody who does not have a lot of background noise going on, if you'd like to unmute yourselves, you are welcome to do that. And you're welcome to kind of mute and unmute as needed. And then for anybody who's not comfortable with that, we also have the chat box for you to type questions in. And also with this presentation, I offer that if you would like to put up your video, and that way I can actually kind of see you and potentially see who is speaking. So if we end up talking over each other, I can kind of monitor that by being able to see who's talking and give people, say, let's have you finish what you're saying and then move on to somebody else. So you could also raise your hand in the video so I can see that and see that you want to say something, and or you can attempt to use the hand raised little emoji so that hopefully I can see you. So I see that somebody's on their job site, which is that's awesome that you're on your job site and taking this time. So yes, loud. So Dane, you can either, type things in, and or if there's something you really need to say, then maybe you can unmute yourself for that, and try to talk over the noise, and we'll all understand that. So um so anyway, as we're going, those things are out there for you. And I also have the ability to mute you and unmute you as well. And so if we're having problems with that, and to open your videos up and stuff like that. So, what I'd like to do, I guess, at first is start the conversation by talking about the framework for even thinking about enclosure issues. There's definitely thought processes that you should immediately be going to if you're seeing any kind of enclosure issue. And so Isabella, yes, you absolutely can respond and ask questions in the chat. That's fine, and we'll keep monitoring the chat for that. Um, what in terms of the framework for thinking about enclosure issues, that framework is the same no matter what climate you're in, but the magnitude and the weight of certain of the ways that we would think about enclosure issues can be different depending upon what climate you are in. And so I really would love for us to go through and have people either respond out loud or in the chat as to what area of the world so if you work in this industry, what areas you work in, and if this isn't something that you actually work in, where you live. And so I'm seeing I've got Rebecca online, so if she wants to tell us where she is.
I'm in the San Francisco Bay Area.
San Francisco Bay Area, all right. And Dane wrote in that he's a general contractor in SLO, and Isabella is a student researcher for Green Building in Santa Barbara. Okay, and I'm seeing that we've got an Angela Lim on, and actually Vicky, I'm seeing you put your video on for us. So you're in Atascadero. Okay, Vicky's in Atascadero. And JA is in San Luis Obispo, all right. So we definitely have a nice amount of people from the Central Coast, perfect. And I've got two hats, regulatory consultant and a homeowner in Los Angeles. All right, Mark. All right. So for the most part, at this point, everybody I'm seeing is in a builder in Santa Barbara is in a dry climate. Some of you are also in kind of marine climate, but even the marine climates in this area are still dry climate. So at this point, I'm not going to be doing a bunch of qualifiers for, say, humid climates or hot humid climates or cold climates or very cold climates. Student researcher in Santa Barbara with SB Clean Energy for the city. All right, Nolan, that's great. Okay, great. Thank you, everyone. And anybody else who wants to put that in, we will be looking at that as we move along. Right off the bat, could just let me know, did you show up today with any specific issue? If there's anybody who showed up today with any specific issue that they'd like to talk about, could you raise your hand? So use the hand raising thing. Okay, do you have somebody in Washington State planning on returning to the California Central Coast? Yeah, so Washington State is a little bit different in the magnitude of how you might think of things, but not that different. Okay, so Rebecca has something great. Rebecca, thank you for raising your hand. And Mark has something too. Perfect. All right, so let's go through the framework stuff, and then we'll turn over and talk to Rebecca and Mark about their issues, and then just see where things go from there. Nolan also. Okay, perfect. So Chloe, you'll help me remember the three people so far who have let us know that they have specific things to bring up. So I think that first we need to define what we're talking about when we're talking about a building enclosure. And so I would really like you guys to respond and tell me what do you think a building enclosure is? What's the purpose? What's the role of the building enclosure in our world? So if anyone would like to speak up, you can, and or you are welcome to type things in. Typing is often slower, which is why I'm inviting you to turn on your mics.
Protect us from the outside elements, I guess.
Yeah, good. Absolutely. Separate living space from the elements. Perfect. So yeah, the building enclosure, separate living space from the elements, it's really an environmental separator, which is basically what Rebecca just said and what Dane has written in, and now Mark is writing in smoke, bug, airtight. Yes, it's an environmental separator, I think is really kind of the nice, really broad way to say what a building enclosure is. And it's the primary protection from those outside elements of rain, of wind, of snow, of temperature, of bugs, of pollutants, of solar radiation, so all of those things. And then we also expect and want the building enclosures that we are creating to maximize heat retention in the winter and to minimize the heat gains in the summer, and therefore give us the ability to actually create a comfortable environment, to be able to create and control a comfortable environment. And in this sense of comfortable, I'm not just talking about thermal comfort. I'm also talking about our respiratory systems, our, just our indoor air quality, just a complete overall environmental separator that we're able to control and make and have it be an environment that works well for us. So in order for us to actually really accomplish that, there are different layers to the building assembly that we need to have. And those layers are basically a water control layer, an air control layer, a vapor control layer, and a thermal control layer. When the enclosure has all of those 4 layers done properly, then we have the ability to truly be a safe, healthy, durable environmental separator. But when we are missing any of those elements, or one or more of them is done poorly or incorrectly, then that's when things can go wrong, and unfortunately they can go very, very wrong. So once we have our definition of the building enclosure, we need to talk about is what are the driving forces against this building enclosure that makes it potentially out of our control, and where we start seeing issues. And those drivers really are heat, air, and moisture is what our biggest problems are. So to understand what those are, we really need to understand the physics of how those things move. And air is kind of the biggest mover of everything. Air carries moisture, and it carries temperature, and it carries particulates and pollutants. So the basic thing of air movement is that we have some kind of hole in the assembly, or many holes. We have cracks, any type of opening in the assembly is where air can potentially move back and forth, and moisture in both its vapor and liquid form can move back and forth. And as soon as there's a driving force, and the driving force is something like a temperature or pressure difference, air is going to move across that hole, one direction or the other. So I've got this picture here that this is the back of a couch. And you can see that basically a switch plate has kind of become imprinted on the back of that couch. So can anybody tell me what you're immediately thinking when you see that, so say I pulled this couch away from the wall to take a look at the wall, and I saw this dirt impingement that showed up on this back of the couch. What does that make you think?
I'm thinking that there is moisture coming through that electrical box. Maybe air.
Oh yeah, and Preston put in air leak. Yeah, so air carries moisture, so there definitely is moisture to some extent. What it's absolutely saying is there is an air leak, and that air leak is bringing with it dirt that is impinging. So basically, the upholstery of that couch is acting as a filter for the dirt. And so the switch plate we're seeing is the color of what the couch originally, the back of the couch would have been. And then the impingement is the dark that we can see the outline. So we know that there's an air leak through this wall. And really, it should be no surprise to us that our switch plates leak. It's someplace that our contractors don't ever think, and there isn't a trade in particular that's responsible for thinking about the fact that our walls are connected to our crawl spaces down below, our attics up above, and that connection is an air leakage pathway through the building assembly. And so there's pressure differences going on, right? Hot attic, air conditioning the house. We've got the pressure, the hot moving to cold from the attic to the house. When we're heating the house and the attic is potentially colder than how much we're heating the house, then the air is moving the other direction. So that air is moving back and forth and it's carrying with it pollutants, moisture. So there's other driving forces, and they've kind of been defined in a lot of different classes that probably most of you have taken. But can anybody tell me when I say driving forces, natural and mechanical, can anybody name some of the driving forces?
Temperature difference, pressure difference in the house, humidity difference.
Yeah, so those are the things that are happening with our driving forces, but we've got a bunch of them that are named and very typically talked about. So somebody wrote in AC, so not quite what I'm looking for, but you're right. And so AC and dryer, kitchen exhaust. All right, so I'm gonna go straight to that one, which is usually the last one that I talk about. But when we talk about things like AC, dryer, and kitchen exhaust, those are our mechanical. That's called the mechanical driving force. And those are the fans that are in our houses. And basically, what Rebecca was pointing out for us were the natural driving forces. And so, yes, Joan, that's what I was looking for. Stack effect is one of our main ones. And then there is another main one that we're typically taught in our kind of basic building science class, and that's wind effect. And I feel like those of us who have gone through any kind of building science training and we've been told about these driving forces, we're not making the connection that any problems that are going on in our building assemblies, these are the things that we need to think about. Is it because of stack effect? Is that mold problem that I'm seeing happening because of stack effect? Or is it happening because of wind effect? Or is it the mechanical effect, the thing that the fact that our mechanical systems can create negative pressures in our homes or positive pressures in our homes? So this is part of the framework of thinking about any of our enclosure issues is which effect is happening and how is it that I can mitigate that effect and where's the source of that effect coming into the building. So the stack effect basically is a great big convective loop that is happening in our homes. It's stratification, which is then setting up a convective loop. So we're ending up with a negative pressure in the winter. The negative pressure is going to be down below. The positive pressure is up high. The heat, the less dense, hot molecules are moving really fast. The air is less dense. That air is rising. It's finding leaks at the top of the building. The air is leaving at the top of the building or wherever that positive pressure is and then where the negative pressure is, which is typically down low. That person is on my emergency list, except they're supposed to know that I'm giving a webinar right now. The negative pressure down below is bringing in cold air from outside because we've got that temperature difference, that physics of airflow. We've got the temperature difference of cold air outside. We're trying to heat the air inside. We've got the hot air rising, making its way out, causing those pressure differentials and causing basically a big convective loop through our homes. And I think a lot of you have probably experienced sitting by a window, especially a single pane window, and or your clients have told you this, and they're sure that the window is leaking, that that window must be leaking because they can feel the cold air moving by that window. And typically, it is not the fact that the window is leaking. It's that they're feeling the convective air current happening, the stack effect, really, at that window. As the hot air, we're heating the air in the house, is brushing up against that window, which is going to be a colder surface. Heat is moving to cold, so it's moving to that cold window, which is cooling that air. So that at some point, that air that was hot and less dense gets cold and it falls. And then more hot air, that the air that we're heating in the home, is moving up that window. And so people are actually feeling this convective current, which is basically a little stack effect, happening at the window. So it's not that the window is leaking, it's that the house overall is being affected by stack effect. Then there's the wind effect. And so once again, this is, air pummeling, say one face of the building, creating a positive pressure on that face. Any leaks are being activated. So air is moving into the building, creating a positive pressure. And then on the far side, there we end up with a negative pressure and air making its way out. So we've got the wind effect, which can exacerbate moisture issues because we end up with things like driving rain during wind events often. And then a kind of a subset of stack effect is our flue or chimney effect. Because we have these intentional penetrations in our buildings. We've got the flue from a furnace. We've got the flue from a water heater. We have, wood burning appliances, still chimneys in our homes. We have exhaust fans. So we've got, those holes, those duct holes going from inside the building to outside the building. So there's these intentional holes that we have to make sure that we control. So we control them with dampers in particular. But we've got that effect that's happening. And so particularly when our chimneys or our combustion appliances are operating, the direction of movement is going to be inside air to outside, which is creating a negative pressure in our house. And that air that's being exhausted needs to be replaced somehow. So we've got that driving force as well that we need to be thinking about. Is it we've got the chimney operating that we're seeing the enclosure issue being activated? And then when those appliances are off, the air movement could go either direction. And so it could be just the fact that we've got these intentional openings, we don't have good dampers in them, or something else is going on with those that we need to be considering and thinking about. And then there's the mechanical effect, and that potentially can be the largest driving force in our buildings because some of those fans that we have in our buildings, particularly our oversized furnaces and AC systems, can have very large fans. And when we've got duct leakage, whether it's on the return side or the supply side, we end up with the effect of pressurizing or depressurizing the building when the mechanical system comes on. So is that what is exacerbating an enclosure issue that we're seeing? Is it mostly happening when we turn on our heating or cooling system? We have all these other fans in our houses as well. The rest of the fans, for the most part, are exhausting air. So they're creating a negative pressure in the house. So our kitchen exhaust, our bathroom exhaust, dryers, those kind of things. So when we see an enclosure issue, we should be thinking about what's the driving force? What exactly is making this issue happen? So some consequences, of these poor enclosure details. kind of from, I'm going to say, least detrimental to worse. So yes, it increases energy consumption in our homes and it decreases thermal comfort for us. But then it can also compromise indoor air quality in a number of different ways, and that absolutely can have tremendous consequences for us. And then, of course, it can actually start destroying our enclosure. Our environmental separator can start to be destroyed because of these enclosure issues that are moisture, air, and heat driven. And then, of course, moisture issues mostly coming down to mold. And also just that's one of our hugest structural issues is moisture problems. So those are definitely some of the consequences. So let's talk about how water enters a building, because water is really one of our biggest problems in our buildings. And so most of us, except for our Washington state person, don't experience that much rain. But when we do experience rain, it can often be quite torrential. And that's when people do end up finding out that, oh, look at that, my crawl space leaks. I wonder if it's always filled up with water and become a pool. Oh, look at that, I have a roof leak. Never known that I have a roof leak. I wonder when that happened because it rarely rains here. There's also air from the soil, right? So actually there's water vapor in the soil. Even in dry climate, there's a lot of moisture in the soil. And that water vapor makes its way up through the soil and gets into the air, and hopefully it stays in vapor form when it gets into the air. But should it find a condensing surface or a material that absorbs moisture, then that material can start to become saturated with moisture to the point at which it either starts to rot, grows mold, or it can, there is a reservoir at which those materials can absorb moisture and also release moisture, and everything's safe. There's can be drying potential with those things. Or we might have these condensing surface like our plumbing pipes, our hot and cold water pipes often are running underneath our homes, and those would be condensing surfaces. Those would stay colder. And the water vapor that's coming up through the soil might find those as condensing surfaces. So we need to recognize that there's a lot of moisture underneath our homes that is constantly trying to make its way up into our homes. And then, of course, there's all the things that we do inside of our homes, cooking and bathing and watering plants and, cleaning our clothes and all those kind of things. And then, of course, there's the random plumbing leaks and things that happen. Potentially there's groundwater and just surface water can make its way in as well. So keep in mind all the different ways that moisture in both its liquid form and its vapor form are moving through our homes, and are they having a way to get in and out of our homes and stay in the vapor form, and or drain if they do come in as in the liquid form. Are they actually making it to our drains? So quick little summary. With enclosure issues, what you should be thinking about is identifying the source. Is it heat? Is it lack of heat? Is it moisture? What's the source problem? And then determining what the pathway is. How exactly is it making its way in or out, and to where? Is it in our wall system? Are we actually seeing it in the interior of the house? Where is and what is the pathway, and what's the transport mechanism? Is it on air? Is it in liquid water? What is that? So we want to begin by exploring kind of the where, how, and why the pathway or pathways are being activated. When we're confronted with the issue, remember that a pressure difference is often the root cause, and it can be exacerbated by the fans in our house. And then to figure out what that driving force is. So let's start with, I think Rebecca raised her hand first. So if you want to tell us kind of what you came today to maybe figure out or talk about.
Yeah, I'm trying to figure out what the best assembly is for a roof. That's over a cathedral ceiling, open beam cathedral ceiling. And particularly, I'm kind of concerned about the vapor barrier, whether it's inside or outside, and I want to add additional insulation. So what I'm thinking about is putting maybe 3 inches of rigid rock wool on the top outside, on top of the plywood. And then I'm just a little confused about what else needs to happen in that assembly to make it safe and waterproof and air sealed and vapor barrier sealed, etc. Or sealed, vapor barrier sealed doesn't make sense, but anyway, I'm just trying to figure out what the best assembly is for that, for cathedral ceilings, that don't have a lot of insulation because they're open beam.
Okay, and it's open beam. Okay.
Yeah, I have 4x12, huge 4x12 beams. I don't know. You can't really
That's
see.
okay. That's okay. I think
See, you can kind of see them above me. I don't know. It's a little out of focus, but so yeah. So
can everybody see my screen?
right.
A picture. Yeah. Is it similar?
Mm-hmm. It is. Yeah, exactly.
Yeah. So you've got the tongue and groove.
Uh-huh.
And you've got the open beam.
Exactly. Yeah.
Okay. So other question that I have for you is the ends of the building, of the room or whatever, attached to any type of attic space? And so I'm going to show you this picture, and then I'm going to show you. So right here in this room, this is actually knee wall to an attic for these rooms back here. And then on this side of this assembly, this is actually a much clearer knee wall for the ceiling over the kitchen area. To this room, this is knee wall. So this is a vented attic over the kitchen here, and on the other side is a vented attic. So do you have an assembly similar to that?
No. For my main roof, it's not that case, but what it does have is there's no attic at all, but what it does have is the main room is, as you see here, and then I have two lower ceiling attached, appended to that, but it's the same, it's.
Do you know for sure that those are part of the conditioned space? Are those even though those ceilings are lower, is the roof the air barrier and pressure barrier, or is the ceiling of those areas the pressure barrier and air barrier? Do you have any sense of that?
I'm sure it's the roof, because I know that there's about 1.5 inches of some ancient rigid insulation on top. That's all they put there.
Okay, and there's no venting. Okay. So on the one hand, that's way better than this assembly that I'm showing you, because so many assemblies, like that very first picture, are confused in that they've got this great big vaulted area, except that, and then it's actually attached to a vented area, and the vaulted area isn't vented, and the vented area is vented, and the two are connected. Okay, so those are very confused roof assemblies. It sounds like your assembly isn't confused, but what's going on with it that you're wanting to figure out what the right thing to do with it is?
Well, we're just super hot in the summer, and we're just wasting massive amounts of electricity in the winter because I have a heat pump. So the heat just goes, whatever comes in or comes out through the roof, as well as through the windows. So, and then I just have the general issue of having been kicked off my insurance and having had to go onto the FAIR plan. And so now the new insurance, the FAIR plan plus another insurance company. So the other insurance company that handles all the leaks and everything else besides fire, they've decided that I need to replace my roof. So I'm thinking, if I'm going to rip off my roof, I might as well also insulate the thing. So that's where I'm at.
Okay. So the biggest problem that these assemblies, let me show you this picture. Do you have much in the way of eaves on your assembly?
Uh,
Exterior eaves,
no eaves. That's part of the problem. I mean,
right, in terms of the heat gain.
yeah, heat gain. But yeah, no eaves. This was really well built in the 70s when we were in an oil crisis, but somehow architects didn't understand basic things. And the main roof actually faces, the main room. The whole house has 100% south north axis. So then all the room, the main rooms face either west or east, and the main room is really west. So just the
Okay,
heat comes blasting in. So
right. Well, but here's the biggest problem with your type of assembly is that the wall to roof, no matter what, is going to have air leakage paths if your framing is going perpendicular to any of the walls, right? So let's take a look at, so see how, whether you've got, eave or not, this connection right here is probably not done well. And every single one of these tongue and grooves is an air leakage pathway. So even if we did your roof correctly as an unvented cathedral roof, vaulted roof assembly, you would still end up, and that's actually the problem that's going on with this house, is they thought that they did this correctly. They put an air barrier above this, but they didn't apply it properly, and they didn't get this connection. So the air barrier on top is fine to the greatest extent. It is stopping the air movement inside the house, kind of straight up into the roof assembly, but they still have all of these air leakage paths, every single one of these. So let's go back to this picture. See how this one, at least, they're parallel for most of the way. So this is pretty darn easy to seal. So if your assembly happens to be like this, then this can be sealed, although it potentially probably needs to be sealed better, but we can seal to this board, right? We can't seal to each one of these in between boards. And on an assembly like this, then you need to air seal here. And so I was just in this house on last Friday, and when I climbed up over here, there was all kinds of cobwebs, which are a huge clue that there's air movement. So if there's air movement, air is coming. This little piece right here is an exterior wall, part of an exterior wall. So there's all kinds of air movement. So I could literally see the drywall wasn't actually even touching the board ceiling over here. And on the outside, there was this nice thick piece of thin fascia board. And I'm sure that was just hiding the air gap that's on the other side, right? So that fascia board needs to be removed, and the wall to ceiling assembly, roof assembly, needs to be sealed. And then we should do it on both sides, the interior and the exterior, right? But if unfortunately your assembly, is the kind where I was, so like this assembly's got it on both edges. No matter what, we've got the boards perpendicular. So I don't know which one yours is. So if you're perpendicular, then Terry Norby, the genius that he is, came up with this. So if your boards are perpendicular, you literally have to get in between them. Now, because yours are open, they're going to be open on the one end, right? This assembly has board on both sides. Yours doesn't. But the point is that we have to get in there. So we're drilling a hole past, so this would be from the roof side, would have this, the roof deck, would still have some roof deck. You need to get in to where that groove is, and then you get your caulk gun. You drill a hole big enough for the caulk nozzle to fit in there, and you squirt in the caulk. Now the problem is that obviously you don't want that seen throughout your assembly. So that's where this wall to roof connection comes in, is that whatever, so they have, this one actually, has glass on this wall, and then, basically this is just a trim board to cover up the fact that the glass can't be sealed to the assembly. But even if you've got, whether it's stucco or whatever you have up there, you need to get to that line, right there, remove whatever trim or whatever is right there. Do that from the top. You can do it from the top or the bottom. You're probably, in an existing home, you're really only going to be able to do it from the top. So getting down to the roof deck and sealing every single one of those, all the way, and then putting whatever your trim or finish is so that you hide that visible caulk. And you don't want to use a silicone. It won't seal it well. So unfortunately, you won't be able to use one of the clear ones. But that's what you need to do first and foremost to get rid of the air leakage pathways. And then we think about, all right, so what's the rest of the assembly? And so let me pull over this. I think you guys will be able to see this if I pull it over here. So I'm going to first give credit where credit's due. So this article is called A Crash Course in Roof Venting, Understanding When to Vent Your Roof and When Not to, and How to Execute each approach successfully. And it's by Joe Stebrick. And this was actually in a Fine Home Building, Fine Home Building is a magazine that's out there, and you could probably find this article online still. And so it looks like it was probably written in 2011. So this isn't a new problem with our homes. But let's get down to the unvented roof assemblies. So you, with your assembly, because it's got the open beam, we're going to, I don't think I have a great picture for the open beam, but basically we're really looking at, you're not going to get any insulation obviously in your beams unless you decide to make a false ceiling. Or I've had some people who have let us, create a drywall ceiling. They weren't in love with their ceiling, but I'm guessing you like your ceiling. I love those ceilings. They just definitely have to be dealt with properly. So above your roof deck, so once you have sealed all of those tongue and groove at the perimeter, you're going to want to do a product, all of your insulation really needs to be above your roof deck. And I don't think I can pull up kind of a better picture right off the bat. But if you go onto buildingscience.com, Joe actually did this assembly to his house. And once we put the insulation above the roof deck, it's a fabulous assembly. The problem is that because we're building the insulation up on the roof deck, and you can use rigid foam, polyiso has the highest R value per inch. Rock wool is fantastic. And another resource is the Build Show, Riser. I'm forgetting what his first name is. But the Build Show on YouTube.
Matt, I think.
Yeah, Matt. Yeah. He shows a bunch of roofs. In fact, he was building his own home with exterior insulation. The problem with when we do exterior insulation, whatever material we choose, that we end up having to architecturally make it not look funky that we've got this built up roof assembly. And so that's just a matter of kind of figuring out the architectural detail of the fascia and having that blend in. beyond that, it's really not that difficult to do this assembly, where right above the roof deck, you're putting your insulation. You won't be able to do any of the interior insulation, so you're going to have to get enough on the exterior. And the other thing is that when you're doing the insulation exterior, if you're doing more than one layer, which to a certain extent is actually advantageous to not do one really thick layer, if we at least can do two separate layers, then what you need to do is that you need to have the next layer either perpendicular or offset, because we don't want that seam between the layer, whether it's the foam or the rock wool, to go straight up to the next level of the roof, where that's going to be where your water barrier is, your ice and shield or whatever you have that's your moisture water control layer on a roof. That's an air leakage pathway, no matter what. Even if you tape those seams well with a rigid foam board, you still can end up with it's not as there's just still a thermal break there. So no matter what, you need to get another piece of insulation on top of those seams. So whether that's perpendicular or whether that's just making the insulation overlap so that it ends up on top of the seam of the layer below it. And so choosing that material, getting the insulation on top, then there's going to be another layer of sheathing. You can do a vented vaulted ceiling as well. So depending on whether you're, kind of what your roofing material is going to be, you might want to have an airspace. So if you're using a clay or a tile already, or a metal roof, then those are meant to have an airspace. And so that's great. They're already meant to have an airspace, so they're going to end up getting put on with that airspace. If you were doing asphalt shingles and you wanted to keep the shingles a little bit cooler, then you could use furring strips on top of the insulation so that you have a little airspace. But then you have your next layer of sheathing. Then that's where, you're, like I said, the ice and water shield. The people are still using building paper, and then whatever your actual roof system is. So
Are you saying that furring strips would be under the sheathing or on top of the sheathing?
they are,
Under the extra sheathing.
yeah, they're actually on top. So they're in between the sheathing. I wonder if I have a picture that I can get to quickly for you.
I mean, it would be asphalt shingles because I'm planning to put solar panels up there. So there's no point in putting clay tiles.
Right. Actually, my vented vaulted ceilings. Yeah. As long as you do the layers correctly, it's a little bit of a give or take whether you actually need that airspace underneath the shingles. It does keep the shingles a little bit cooler, but not finding the image that I was hoping I'd find.
Just to prevent the heat transfer.
Yeah,
That's what you're saying.
it's just the shingles can absolutely hold up to the solar radiation. It does keep them a little bit cooler and extends their life a little bit if there is that little bit of airspace. But it does make the assembly that little bit more complicated. And as it is, you're probably going to have a little bit of a hard time finding a contractor in our area that is familiar with it or comfortable with doing this stuff. So you need to find somebody who can really draw the details up for you for a contractor. So definitely check out Building Science Corps for their details on how to do it, and Matt Reisinger. The biggest problem is that also, they're going to be talking about some of the problems that we are less susceptible in a dry climate, but they're going to be talking about very safe assemblies for a dry climate. Their assemblies are going to be incredibly safe for a dry climate.
So what kind of person would be able to draw up those kind of details?
Um, so, so the instructors from that 3C Ren has give classes all the time who are architects and DPs, and Jennifer, what's Jennifer's last name? Chloe Garnett?
Rennick. Yeah.
Garnett. Yeah. So they should absolutely be able to drop those details.
Okay. And I'm assuming that I will also probably have to talk to a structural engineer because I'd be putting all this extra weight on top of the roof.
Ask them. They would know for sure. Whether because yeah, I'm not 100% sure in terms of the weight and stuff like that. So yes, you may on an existing building, you may need to talk to a structural engineer. And they, if anybody, would know of somebody who kind of who understands better what's being asked. So, all right, I hope that helps.
Great. Thank you. Yeah.
All right. All right. So I think it was it Mark? No, Dane. I think Dane.
I think Mark had a question. He had his hand raised, and he also has a question in the chat. And then I think Nolan also had his hand raised at the beginning, but we got a couple other questions in the chat. So
Let me.
I think if anyone who had their hand raised initially wants to unmute themselves, you can start there.
Sure. Well, Judy, I mean, that was really helpful. I think you probably covered half the questions I had with that last one. So hopefully my questions are equally applicable to others. So, I know I have about 13 ACH at 50, so it's a pretty darn leaky house.
The tent.
Yeah, it's like I might as well not even have an enclosure, right? I mean, it's at that point.
All right.
So, my questions were kind of similar. I'm looking at electrification, retrofit, and realizing the connectedness of all the systems. One of the first questions is just the vented versus vented attic. And I know you showed some stuff about that, but when I'm thinking about that, there's all the considerations that go with it. You touched on the roof assembly question, but it's, if there's a vented versus unvented attic, it seems like the ceiling joist insulation method and sealing that lid would be the solution there, but also thinking about a heat pump water heater installation, taking advantage of that cooling and going into the attic, and is there condensation? So it's like the interconnectedness between the heat pump water heater ventilation considerations and negative or positive pressure. And then, thoughts just on monopoly framing versus modified monopoly framing, and zip systems being non-permeable, they're pretty vapor closed. So is there a certain peel and stick recommendation? I'm just going to stop there, but there's other things that we can kind of get into.
Okay. And so is there I guess maybe starting with your ceiling assembly in terms of choosing vented or unvented, what are you starting with?
It's a vented attic, no insulation anywhere.
No insulation anywhere. And is that because you've cleared the insulation out, or it's just an older home that didn't have it?
Older home, it hasn't been done.
Okay. Yeah. So it's a large undertaking to do any of the unvented ceiling assemblies in an existing home, unless you're willing to do one of the two-part spray foams, which I'm not a fan of. But there are thousands of homes that have done well and fine with the two-part spray foam. So I don't know, but basically that's the simplest way, as long as your attic is actually accessible, to do an unvented assembly. But I'm going to show you. So this is a house a new construction. It was just finished last April. So the attic is a spray foamed attic. It's an unvented assembly. The spray foam contractor this is Lennar Builders, I guess I'll call them out, doing huge subdivisions. They don't understand where the actual air barrier is. So this is one of the exterior hip gable ends, and there's the spray foam should have gone all the way down to the ceiling drywall. So so is this a huge flaw? The house is still fairly tight. Um, it would be tighter, and it would have, and this is a place where air moisture and heat can move in and out of the assembly. So, and this is open cell spray foam, which I'd rather you use closed cell if you were thinking about that. But anyway, so if you were thinking of doing the spray foams, you probably need to follow behind and make sure that that they're actually understanding and doing it correctly. Vented roofs, especially in our climate where we don't have the exterior humidity, and Mark, you are in the Central Valley.
LA, Los Angeles,
You're in
coastal
LA.
LA.
Okay.
Yeah.
Yeah. So vented assemblies can work absolutely fine in our climate. I guess the biggest thing with a vented assembly in our climate is if your duct system is going to be up in the attic. Is that the case?
It most likely will. I mean, it currently is, but it's only heating, so I'm going to
And
add cooling.
yeah.
Yeah.
And I'm going to say that that's fine. I do systems in the attic all the time. The thing is that in our climate, so not hot, humid people, if anybody signed on who's hot, humid, they're going to have a heart attack when they hear me say this. But in our climate, we need to deep bury our ducts. So we can do our ducts in the attic. They need to be low against the joists. And then they need to get buried in, blown in cellulose or blown in fiberglass as your insulation. They need to be covered. And a study just came out. We have these research houses in the Central Valley where we do all kinds of research, and they just did research on deep buried ducts in attics versus ducts that are longer runs and up high in the attic and not deep buried. So we need tight duct systems and bury them in insulation, and they're good, and the duct system is going to work just fine in a vented assembly.
Okay.
And
So,
yeah, go ahead.
yeah, so or a vented attic with proper air sealing at the lid or from the attic, and then deep buried ducts, and then if you do an ERV, that would kind of be up in there too. Okay, well that sounds pretty reasonable that way. You don't have to kind of deal with, and then what about we don't have to figure out the other air tightness considerations on like the actual wall assembly retrofit. So it sounds like the roof assembly is not going to matter too much because all the installations at the yeah.
Yeah, no, just but air seal at the ceiling assembly, at the ceiling. So all your can lights, all your top plates, interior top plates, exterior top plates, plumbing penetrations, electrical penetrations,
Got it.
do a good
Yeah,
air.
I think my framers kind of forgot their tape measures at home when they like built the house because I was not looking forward to like cutting all the rock wool to like each individual bay.
Yeah, no, do a blown in. Do a blown in.
Yeah.
And then and make sure actually that, and we're getting close to our end time already. Make
Yeah.
sure that all the fascia board at every single bay, that's even the ones so all the bays that are not intentionally vented, air seal those, because we don't want wind washing through the insulation, especially a blown in product that'll get actually blown away. It won't only be wind washing, it'll actually blow the insulation away. And we want full insulation coverage. So make sure that you air seal each one of those eave blocks. And then in your vented bays, you need to put baffles in so that the air travels in
Yeah.
and then up above the insulation level so that that venting, does end up venting the attic. So make sure that you get those baffles in and that they're actually sealed. So they should be sealed out at the exterior top plate, sealed to the rafter bays so that that air has a nice smooth channel to travel up through without being obstructed and without wind washing.
Okay.
And then each one of these eave blocks needs to be sealed as well, so there's not wind washing through.
So that would be a
Yeah.
job for like spray foam, like consumer spray foam,
The one part low expanding spray foam. Yeah. And get a
Yeah.
professional spray foam gun. There's ones with really long nozzles if it gets really tight at your eaves, so that you can reach into the eaves and get that done.
Okay. Well,
So
that's
this one
like
has a
awesome.
soffit. Yeah.
And then I could possibly do the exhaust from and then maybe I'll have to talk to somebody about that. But like, is there risk in the cold air from the exhaust on the heat pump water heater creating moisture
Does the
issues in
heat
the
pump water heater have to go in the attic?
No, it's not gonna go in the attic, but it's in a tight closet where it could be vented or louvered, and it's like, would there be benefit in exhausting the cold air into the attic? Is there too much moisture in it? No.
Yeah.
Okay.
There's too much moisture in it, and it doesn't have enough of a cooling effect. And once you actually do like an R38 and deep bury your ducts and your ceiling plane are really basically in conditioned space at that point in time because they're insulated so well. So
Okay.
trying to cool that air that's above that insulation is of no additional benefit
Yeah. Yeah.
because we've got
Okay.
enough insulation at that air sealed roof at that air.
Well, that seems like that saved me quite a bit of money by doing this approach instead of monopoly framing and exterior insulation to the nth degree and all that stuff. So that was very helpful.
Yeah. And so I'm gonna so our hour is up already. I'm so glad you came with these questions. I'm going to switch
Judy,
back to our other slide thing so that Chloe can
Judy, if you have more time available, I'm happy to stay on to answer more questions. But if you have something else to get to, I understand.
Okay, no, actually I do have more time. Mark, I do want to say one more thing is that you mentioned an ERV, and
Yeah.
in our climate, we really want an HRV.
Yeah. Okay. HRV. Yeah.
Yeah. And so do you know the difference?
Yeah. Energy versus heat. Yeah.
Yeah. And the reason that we don't want an enthalpy recovery ventilator, often called an energy recovery ventilator, the ERV, is that our homes have more moisture inside than our areas outside. So what's going to happen with the energy recovery ventilator is it's going to actually be bringing the stale inside moisture back into our homes rather than keeping hot, humid air outside of our homes, which is what the ERVs are good at doing, is keeping hot, humid air outside of our homes. In our climate, we generate more moisture inside of our buildings than is outside. And so it just ends up bringing that moisture back into our homes. And really, we need help getting that moisture out of our homes. And the heat recovery ventilator won't over dry your home.
Okay. And we didn't talk all about crawl spaces today at all, but I mean, any just general thumbs up, downs on sealed versus unsealed crawl spaces?
Sealed crawl spaces are great. What is the absolute most important for our climate in terms of crawl spaces is, let me get back to this one. Is it going to do it? There we go. Let me find. Is the ground source vapor barrier.
Ah, okay. So some Stego or something.
There is so much moisture underneath our homes that we can end up with rotting at our attic sheathing just because of the amount of moisture that's coming up from our crawl spaces through our house and then finally finding both the roof deck as wood, that it's going to absorb that moisture and that potentially is not going to dry out fast enough, and rusty nail heads, so that all those nail penetrations are places where that moisture condenses and then starts to rot our roof decks out. And this is actually from a contractor, and this is a house that was up all the way in Mount Shasta, so a much colder climate than we are in the winter. But the problem is the same, is that there's just so much moisture in our crawl spaces. And this homeowner actually had condensation on their windows, brand new house. The house was only 3 years old when this contractor was called in, and they had condensation on their windows, and he found the rusting nail heads and the rotting roof deck. And the only thing he did was put down a ground source vapor barrier, and he solved all of those moisture problems in the house. And so this picture is of one that is a sealed, unvented crawl space. Like I said, that they're great. They can be great in our climate. They can be expensive and difficult to actually make happen. As soon as you put down a ground source vapor barrier, we can actually get rid of the majority of the venting in the crawl space. So you can reduce the venting tremendously. I think we only need 1 square foot of venting for every 1,500 square feet of floor area. And so basically you can often go down to just 2 vents. They should be on perpendicular sides, so they don't have to be on the same, but one should be like on northwest and the other one should be east, north south and east west, so that there is some cross flow for whatever air is being moved through the vents. But you can greatly reduce the venting in the crawl space. You can just lay it on the ground. It doesn't have to be taped really well. It's great if it is, but the thing is that with a vapor barrier, it doesn't have to be perfect for it to do a good 90% or
So you
so.
don't need to bring it up the walls and get it like go crazy with the metal bars and then put some polyiso on the foundation stem
You don't have
walls.
to. Yeah. I mean, like if you really want to, that's going to be fantastic, but it's going to die. We call it the 90% solution, just putting down, a good mill. It's great if you do tape the seams, make sure that it's not touching any of the wood. Make sure that
Yeah.
it's only taped to the concrete piers. Yeah, so getting down that ground source vapor barrier should happen in every crawl space, everywhere.
Yeah. I mean, you watch like the build show and all these things, and it's like, you need to do everything perfectly. And then it's like, well, and then you get quotes, and it's like, well, it perfectly means like a lot of money.
Yeah,
So,
it is. And, and in a lot of ways, we're very lucky with our climate. That was kind of that magnitude thing I was talking about at the beginning, is that other climates, the magnitude of the problems are so much greater, and the humidity outside is such an issue. Like it's ridiculous to have a vented crawl space in a humid climate. It's just bringing even more humidity underneath your home. We don't have that issue, so we don't have to be as concerned about making the unvented crawl space. And once we lay down that vapor barrier, because our crawl spaces are supposed to be that that water vapor makes it out. But if there's no temperature or pressure difference, that there isn't the movement, we're not getting that water vapor out, and its path of least resistance is up through all the holes in our subfloor and in our floor. So then it ends up in our house, and then it makes its way up into our attics, and we can end up with problems all the way up at our roof deck from the moisture that is from the soil of the crawl space. So getting that ground
if I
source.
could just ask one quick question. Hopefully this is like a really common thing. I was always like zip sheathing and it's gonna like be awesome. And then talking with some passive house folks, they're like, well, you got to watch out because like it's not permeable. Do you share that concern with zip? Just CDX with like a peel and stick wrap is kind of the way to go.
Well, so in terms of our walls, once again, dry climate, we can, and the kind of the best is if our walls can dry in either direction. So having them vapor open in both directions is fantastic. We typically aren't going to get that if we decide to do exterior insulation. And so if you really want, and I absolutely recommend exterior insulation, but once we start talking about exterior continuous insulation, we absolutely have to make sure that our interior wall is vapor open, vapor permeable. And once we're talking about exterior insulation, whether it's, whether it's because of the zip or the fact that we're using polyiso as our exterior insulation or whatever, we're pretty much ending up with a vapor impermeable wall at that point in time. So on the exterior, so we absolutely have to make sure that we're not using vapor permeable paints or finishes on the inside.
Oh,
That we've got that vapor permeability for the inside. And now since your house didn't have ceiling insulation, I'm guessing it never had wall insulation.
there's absolutely none. So
Yeah. So this was something that I really wanted us to talk about today, is houses with uninsulated walls. It is not, unfortunately, safe to just decide to insulate the walls of homes with uninsulated walls. We really, even in our climate, we need to make sure that we have all 4 of those control layers that I talked about at the beginning, that you've got a really good water control layer, vapor control layer, air control layer, and then your thermal control layer. And what's typically missing is our water and vapor control layers and the air gap, the drainage plane. So we've got the drainage plane, which is part of the water control layer, where any water that condenses or any water that gets into the wall, because most of our claddings actually absorb moisture. And the sun will hit our claddings. And so whether it's the dew from the night before, or it rained and we've got moisture on the walls, or we've got shrubs up against our houses, which we love to have, the moisture from the shrubs gets driven into the walls and it needs a place to drain. So that our water control layer is where that water hits and it's supposed to drain down, and it's supposed to, whether we've got the weep screed on the bottom or some kind of opening at the bottom, for the water to drain down and out. But we also need to have an air gap. And that's what's typically missing in our walls, as well as actually a good water control layer in our walls in Southern California. We often just don't have an actual good water control layer in our walls. And so I don't know how far you were planning on going in terms of removing cladding, or what you were thinking of doing. But you really need to make sure that you've got what we're calling a well-drained wall system. And so this is the water managed wall system. That this picture, the well-drained walls, is from a Joe Seabrick article in JLC 2003. And so take a screenshot of this slide so that you have that link to the full article. And then there was another article on his buildingscience.com website that I saw, the drainage planes and airspaces, which explains the airspace thing. The thing about Joe's articles is he very rarely will actually distinguish specifically about dry climate versus all the harder climates. But for the most part, the information is applicable. And you need all those control layers before you can safely insulate our walls. And one of our biggest problems, since rain is not our biggest problem, but because of our huge rain events, but the fact that they stop and the sun comes out, is that in uninsulated walls, there's a tremendous amount of drying potential. So even though liquid water gets into our walls, we often don't ever know it in our homes with uninsulated walls, because there's so much drying potential. The place that we end up causing major problems in our own homes when we do start seeing moisture issues is because we irrigate our homes. We think we're irrigating our landscaping. So I don't know what's around your home, but so many of us have landscaping right up against our homes. We've got sprinklers right up against our walls, and not only are they watering the soil and the plants, but they're watering our walls, and they're turning on, every day, every 2 days, every 3 days, whatever. They're turning on often enough that and they are potentially on the shaded side of our home, the north side of our home, and we end up with we lose the drying potential. once we put insulation in those walls. And so were you thinking of exterior insulation, just interior in the studs? What have you been thinking?
I mean, folks have recommended some drill and fill, but I think that's like the pitfall of not, having the, whether, uh, the water thermal,
Weather
you're
resistant
having all
barrier.
three,
Yeah.
all four, and then yeah, is that just going to create more? If I tighten up my house and then throw some blown-in insulation in the walls, and then I'm like creating a recipe for disaster when I have this super leaky house that dries really
It
well.
dries. That's got a huge amount of drying potential, but it's hard to
Yeah,
condition.
so it's
That's
like, okay, knocked off the stucco, see what's under there, and then resheath it. Yeah, what do you do about the eaves? And it's like, okay, do I, chop them off? Do I sister them? Do I put a subfascia and then just run the CDX up to it and then kind of line it on the bottom of the eave protrusion, subfascia, and then house wrap all that stuff all as one continuous, like a modified Monopoly framing, and then put my rain screen on and then the finished, product.
Yeah, so it's really so your exterior is stucco.
For the most part, and then some wood siding that 100% has to go because it's south facing. It
Yeah.
just needs to be painted every couple years.
Yeah. And so definitely the stucco in particular, but wood as well. Absorb they're hygroscopic. They absorb water. They definitely have a nice reservoir amount of water that they can hold before any problems get caused. But as soon as we put insulation in the walls, we are making it so that they cannot dry as much or as fully. And so that's where it's important. And so one of the things, and are you tied to going back to what you have, but with different, better
No,
materials?
just yeah. I mean, lowest cost plus. I'm in three fire zones, like in the remapping from Cal Fire. There's like 20 homes that were not in the fire zone, but I have three converging fire zones all around me. Literally, and there's 20 homes not in that. So I'm like, I need to protect myself from that by having
Yeah.
non-combustibles.
So you should be looking at Vulcan vents for the vented attic assembly we
Yeah,
were about.
yeah.
So they have an intumescent coating that when they heat up enough, they seal off. So hopefully they stop the embers before the embers end up getting through there. So your cladding, want to be looking at hardy board, stucco potential.
Metal.
Metal,
Yeah,
yes,
hardy metal
metal,
stucco.
yeah, hardy border metal. And yeah, and I have actually been trying to get an answer about the drainage space, the rain screen, the drainage space in walls in our fire zones. And nobody's been able to answer me, and nobody has, I don't know, seemed to they really want to brush the question off. And I would almost submit no, because they brush it off. They just don't get
The
it.
passive house people have been talking a little bit about that.
I'm sure
Yeah,
Bronwyn might have
they
some ideas on
haven't
that
been
too.
satisfied with how no so I've actually put a bunch of questions into the passive house webinars that have gone on 3C Ren, and none of them have understood or answered the question well.
Yeah, Bronwyn seems to have a lot of knowledge. Maybe Ken over at PHN knows over there. I mean,
You can check. I can just tell you that the passive house people that I've heard present and that I've asked the question of have not given good answers whatsoever.
is
So
there a vapor water resistant like barrier that you recommend? I mean, I know there's no silver bullet, and the question always is it depends, but is there like a certain perm rating you're looking for, or is like pro climate hero? I mean, is there a certain thing that just seems to work in our climate?
no, they'll work in our climate and blue skin, or I mean, like all of it will work in our climate. Once again, it's the fact that if you're making the choice to not have the vapor permeability on the exterior, you absolutely need to make sure. And part of making sure you've got vapor permeability on the inside is not pushing furniture up against, like right up against a wall. And because we need the airflow on the walls so that the wall surfaces don't get too cold in the winter and too cold in the summer when we're air conditioning. because we will end up with mold growth when we have when basically we stop that vapor movement with furniture, with mirrors, definitely not any kind of like vinyl wallpaper or anything like that. So, give yourself, you know, permission space to, I don't know, talk to, whoever has the aesthetic or whatever. So, want something pushed up against a wall. Don't let things get pushed up against the wall if you have stopped any drying potential to the exterior in particular. And this happens in houses where the drying potential is open on both sides. So we have to be careful about letting the air actually be able to wash all of our exterior surfaces, your interior.
Yeah. So the perfect wall kind of Joe Brick stuff would be applicable for our.
Oh, yeah, absolutely. But and so he has a dry climate zone book on his website that you can purchase. It's technical, but it definitely kind of gives the parameters, and the perfect wall is really perfect for our climate because we can deal with the vapor permeability both directions. The fire zones, on the other hand, and kind of some of the things that we want to do with that, mostly we still need the 4 control layers. My biggest question is whether that the airspace that we typically want between at our drainage plane, whether that ends up being an issue in our fire areas. And so it's, like this is this wall, they're using furring strips to have that. With the stucco, actually two layers of building paper are going to actually give the enough space between the 2 layers. And so that is the one that with a stucco assembly and 2 layers of building paper, one is going to end up sticking to the mortar and the stucco, but it actually ends up pulling away from the second one, which then gives us a bit of an airspace. And so that might be a better solution for rather than putting in that distinctive airspace that we really want in some of these other assemblies in a WUI zone.
Then like an XPS or polyiso would be out because there's just no permit out.
Yeah, for your continuous installation.
Yeah.
I love the conversation that we're having here. I do want to make sure we've got time to get to some of these questions that are in the chat. A quick one that Preston asked a little while ago about the study you referenced, about the deep buried ducts. A clarifying question about that, and then JA also had a couple questions in the chat. I was hoping to get to quickly.
So the deep buried ducts is about ducts that are technically in unconditioned, in vented attics, so non-conditioned attics. Those attics get hot. Once you have an unvented attic, your attic should not be getting hot. That's the point, is that attic is part of conditioned space. So we still need R8 on our ducts, really. You can get away with R6, but I really prefer R8 on our ducts. And our ducts should always be tight, and tight is not building code. Building code is not tight. Tight is, I'm going to say 15 CFM or less. I'm giving you a number. 15 CFM or less is what you should be holding your HVAC contractors to. That is a tight duct, and I don't care. And so the point is that it doesn't matter about the capacity of the system that the ducts are connected to. And that's our part of the problem with building code, is that duct leakage is a percentage of the nominal airflow of the capacity of the equipment. And so there's a whole bunch of nominals, and nominal means not really. Nominal means, could be this amount. So hard number, 15 CFM or less are tight ducts. If you get 20, okay, any more than 20, you need to get lower. So no matter what, we need tight ducts, even when the ducts are in conditioned space, because I want the air to be delivered to the rooms that in the quantity that room needs for the energy of that room to be offset. So whether that's heat, hot heat in air conditioning, or whether that's cold air in when we're heating, I want the air to make it from the system through that duct into that room. I don't want it just leaking out randomly throughout the house. That's not helping the house overall, and that's not helping the air mixing, and that's not helping the loads on each particular room. In our vented attic assemblies, we need to deep bury the ducts. They need to be low at the joists and deep buried. Mark, one other thing about, so with the ground source vapor barrier, we can reduce the venting. So you should absolutely reduce the venting, and once again, use Vulcan vents for the couple vents that you're going to need on the crawl space, so that in a fire, those vents close themselves up.
And one would be on the north and one's on the south, or like one's on north and
No,
one's
so the
on
opposite.
west.
Yeah. So if one's on the north, then the other one needs to be on the east or west.
Okay, so like
Cross
adjacent.
flow. We want, like, we don't want
Adjacent side.
free flow. We want, yeah. All right. It's okay. Chloe, what else did you want me to address?
JA had a question from further up in the chat. From San Luis Obispo area for a new build, what is the best recommended rigid exterior enclosure in a WUI area, and where this and energy efficiency is the priority? Is there a certain product recommendation?
I don't have a particular product recommendation for your exterior. So I'm guessing when you say rigid exterior enclosure, you're talking about continuous insulation on the exterior of your building, JA. And rock wool actually is probably one of your best choices in a WUI area. I very often have done polyiso, but the foam products can melt and have problems in a fire. So rock wool is a much safer material and much more fire resilient. So I'd be looking at rock wool as my exterior insulation in a WUI zone. So I hope that answered that question. And I saw also that, Jay, that you were asking about a link for the perfect wall, and go to buildingscience.com, Joe Steebrook, and type in building wall in his articles. I don't have that link in any of my, like readily accessible. I just go to buildingscience.com and grab and look up his perfect wall. Okay, Chloe, did you see anything else?
I think that might have been almost everything. I'm just throwing that link in for the perfect wall article to the chat now. But if anyone did have any other questions, you can email us. My email address will be on the slides that are going out with this recording later. And all of these questions are great potential topics for future discussions. If we have a lot more questions, we can absolutely do another one of these office hour style trainings in the future. So let us know. And it was really great to see all of the engagement and discourse today. And since we are over, I'm happy to skip these slides. I think most of the people on have been on our trainings before and are familiar with what I'm going to go over, and they'll all be in the slides that get sent out to you in an email in a few days, so you can look through it. Quickly, I'll plug that we do have a Passive House in-person event happening this fall. It's totally free to anyone in the region. And this year, we're also covering accommodation. So if you'd like to come, please apply. We're super happy to have anyone who's interested in learning more about enclosures and having a hands-on opportunity to work with the Passive House standards. And with that,
Preston just put something in the comments to definitely reach out to a structural engineer for our over roof exterior insulation. So thank you, Preston and Rebecca. So definitely he's saying that the loads are more than what we think. So awesome. Thank you, Preston. And thank you, everybody. And thank you, Chloe.
All right, with that, I'll go ahead and end the meeting here, but thanks so much to everyone for joining us today. And I hope to see you all on a future webinar soon. Bye.
All right, bye-bye. Thank you.